We must first understand the Android system source code directory structure to lay the foundation for AOSP learning. So let's get started. If you haven't downloaded the AOSP source code yet, you can use cs.android.com to read through the source code and follow along with these tutorials. Or if you want to download the AOSP source code, please follow the instructions from AOSP download tutorials. So the basic idea of this session is to give you a very high level overview of AOSP folders. So we'll go through each folders one by one, and I will try to explain what each folders are meant for. So the first folder we have got is ART, which stands for Android Runtime. So this folder contains the modules related to Android Runtime operating environment. All the ART related modules can be found here, including DEX compilers, JVM, Dalvik VM, etc. I have opened the AOSP project in IntelliJ. So here you can find all the folders coming under the AOSP project. So the first one is ART, which stands for Android Runtime. So as we discussed, it contains all the dependent modules required for the Android runtime to function. So here we can find the Dalvik VM and the OpenJDK VM, and similarly there are a lot of other dependent modules which are necessary for Android runtime to function. So next is Bionic. Bionic is Android's custom C library, math library, and a dynamic linker. So you can find Bionic here, and inside that you can find all the library and supported modules for C and C++. So if you open the README, you can read more information about different folders within Bionic. So for example, libm, this folder contains all the modules for the math library, and similarly libc contains all the C related modules, and the dynamic linker interface is available in libdl, and the lib standard C++ is available in this particular folder. And the dynamic linker and the unit text can be found here. The benchmarks can be found under this path. Next we have bootable. So the bootable folder consists of the boot related code. So it contains the bootloader, OTA, over the air update, and some modules for the recovery mechanism. So in IntelliJ we have the bootable folder here, under which we could find the bootloader and the recovery folder. Next we have the build folder. So the build folder consists of the make files for the build system. So you can find the env-setup.sh file here and some common shell scripts, and also there are folders for the make, soon build systems here. So make and soon are the build systems used by Android. So these build systems are used to build the entire AOSP project. So in IntelliJ we have the build folder here. So under the build folder we can find the soon, make, and there are many other supporting modules which are needed for the build system. And at the root you can find env-setup.sh. So env-setup.sh is the configuration, environment setup configuration shell script which we run before we start using AOSP. So if you open it up, you can see all the commands which are available within that. So if you have already built your system, you have definitely used it. So you first run env-setup.sh, and then you give the launch command, which actually gives you the launch menu where you select one build variant, and this shell script contains the logic for all the commands which you execute in the terminal. So for example, M stands for making the top of the tree. So you can find all the descriptions here. So we'll cover env setup in detail in a separate video. Next we have the CDD or compatibility definition document. So this folder consists of the documentation. So this documentation you can also find it online. These are instructions given by Google which the OEM has to follow to be compatible with the latest Android release. So CDD can be found under compatibility folder. So under this, if you go, there is a folder called CDD. Inside CDD there are multiple sections, like we have 13 sections. So and each of these sections are dedicated to different topics. For example, this one is dedicated to device types, and within device types you can see different device types supported by Android. So for example, handheld device requirement. So this is specific to mobile devices, the mobile phones. And similarly we have television. So this is specific to television OEMs. This is applicable for all the OEMs who uses Android as the operating system for television. Similarly, we have watch. This is for the wear devices, and we have automotive here. This is for the Android automotive build. So with each of the new versions, there will be changes to this documentation. So similarly, you can find for each topics here, like this is software, and then the application packaging, multimedia, hardware, performance and power. So next we have CTS. CTS stands for Android Compatibility Test Suite. So here you can find all the modules to run the CTS tests on your device. So CTS tests ensure that your implementation is compatible with this latest AOSP build. So basically under CTS, it will run a huge number of APKs or programs which will check different implementation of your build. So in case if one of the implementation fails, it will log that in the report. So at the end of CTS run, you will get a report mentioning whether it was successful or it was failure. So you can find the CTS tests under the CTS folder. So if you want to learn more about CTS test and how to run this, how to start the CTS tests, then you can look at source.android.com. So there you have detailed information on how to run that. You can find all the CTS modules under this particular folder.